Good morning, evening, or afternoon to everyone. My name is Salma, and I'm going to be joined by my teammates David, Gabrielle, and Noam in presenting to you guys one of the most powerful and dramatic phenomena in the universe, stellar explosions. Our research question that we've been going over and kind of just diving into the last couple of weeks, our biggest question is, are there any stars, and particularly supermassive ones, that could pose a potential threat to our own solar system? We chose this topic because stellar explosions are not just breathtaking cosmic events, and they're beautiful in many colors and just in their intensity, but they also have some real implications for the universe and potentially for Earth at the end of the day. These are massive explosions that release enormous amounts of energy, and sometimes it even outshines entire galaxies, which we've come to learn. For very short periods of time, but nonetheless, for anything in space to be outshining an entire galaxy is something to pay attention to. So, given all of that information, what happens when these explosions occur relatively close to our own solar system? Could they possibly pose a risk for us Earthlings on Earth? Or what's to do about predicting whether or not they will be a harm or not? And that is what me and my teammates are going to be exploring today.
Good evening, everyone. My name is Norm, and today I will be talking about the life cycle of stars, stellar explosions, and cosmic threats that could potentially impact our solar system. We believe that in order to answer our big research question, it is important to understand a star's life cycle. A star is born when a massive cloud of gas and dust collapses under gravity, forming a protostar. This is also known as a stellar nebula. The second phase of a star's life is when the star fuses hydrogen into helium in its core, producing energy and maintaining stability. From there, in its later life, it becomes a red supergiant. This is when the star exhausts hydrogen and starts fusing heavier elements, causing it to expand dramatically. When a star has left the red supergiant phase, it becomes a supernova slash hypernova, which is also known as the death of a star. This happens when once iron builds up in its core, fusion stops and the core collapses, leading to a powerful explosion. From there, the aftermath of a star's life disperses elements into space, which contributes to the formation of new stars and planets. It is important to note that there are three different types of stellar explosions. There's supernovae, hypernovae, and gamma ray bursts. A supernovae is a stellar explosion marking the end of a star's life. When this occurs, it releases immense energy, briefly outshining entire galaxies, and it is essential for creating and spreading elements like iron and gold. There are many impacts of a supernovae on the universe. Some of these include element formation, which creates the building blocks of planets and life, star formation, which sends shock waves triggering new star bursts, neutron stars and black holes, which some supernovae leave behind, and cosmic radiation, which can cause a nearby supernova within 100 light years to affect Earth's atmosphere.
You might ask yourself, what if one day the sky lights up with the explosion of a star? Would that be the end of all life as we know it? Let's find out more about this. The first type of stellar explosion that you can encounter is a supernova. A supernova is an enormous stellar explosion marking the death of a massive star. Could a supernova threaten our solar system? The closest star to us that could potentially go supernova is a star called Spica. Thankfully, Spica is over 250 light years from us, on Earth, and that is too far to affect us. Any stars within a closer range that would be able to affect us won't be going supernova, or at least not anytime soon. And according to earthsky.org, if our sun exploded as a supernova, the resulting shockwave probably wouldn't incinerate the entire Earth, but the side of Earth facing the sun would boil away. Scientists estimate that the planet as a whole would increase in temperature to roughly 15 times hotter than our sun's normal surface temperature. The next type of stellar explosion is a hypernovae. These are caused by even bigger stars having the period of stellar death. So a supernova or a hypernova, excuse me, is simply put a much more powerful version of a supernova. And you might ask yourself, could this more powerful explosion, could a hypernova threaten our solar system? And that depends on the scale of the energy release and its proximity to Earth. And those things will determine whether it has an effect on the solar system and on Earth. Um, and to build on that, hypernovae near Earth would almost certainly not be seen anytime soon, so it's safe to say that we are now safe from both supernovas and hypernovas. But to put it in perspective, though, a supernova versus a regular explosion, a supernova is like a massive TNT explosion releasing energy equivalent to billions of nuclear bombs, but on a cosmic scale. A hypernova versus a nuclear bomb. A hypernova is even more extreme, comparable to the energy of millions of supernovae, unleashing powerful gamma ray bursts that can impact entire galaxies. And on the topic of gamma ray radiation and gamma ray bursts, the most powerful explosion in the universe is a gamma ray burst, and these are caused by very, very massive stars at their point of death and can even result in a black hole. So gamma ray bursts, or GRBs, are defined as the most energetic explosions in the universe, releasing more energy in seconds than our sun will in its lifetime. They often happen after a hypernovae or with the merging of neutron stars. Could a GRB from a massive star affect Earth? GRBs are extremely powerful, but are also very rare events that happen in space. Gamma ray bursts only affect what is directly in their path, reducing the risk to Earth. This is called a directional path of a GRB, and it's just like a flashlight. Where it's pointed, that's what gets affected. So Earth would be just fine.
Okay, so let's wrap things up a little bit so we have some final thoughts. While supernovae, hypernovae, and gamma ray bursts are incredibly powerful and absolutely amazing, they are unlikely to threaten the Earth due to their distance and rarity. So even though it is something that is potentially catastrophic, it's not likely that it's ever going to really reach us. It's not likely that it's ever going to truly become a problem with us. It's not something we need to necessarily do too much about. In conclusion, no supermassive stars currently pose a direct threat to our solar system. While cosmic events can be powerful, the vastness of space makes Earth relatively safe. And that's a good thing. Like, thank goodness, that is fantastic. There's a lot of very powerful interstellar events that go on. They could be with stars, they can be with planets, whatever. It doesn't matter. But because space is so vast, we will never truly know all of its depths. Earth's doing pretty good right now. Earth is chilling. Earth's been chilling for this long. We're doing okay right now. So here's some things that we've learned. Number one, Earth's atmosphere is a very important protective shield. Without it, we would probably be subject to different a lot of different bad effects from space, like, whatever's going on. We'd be more like subject to like meteor and things like that. Second of all, the likelihood of a dangerous stellar event occurring near us is extremely low. Again, thank goodness, this is a good thing. The protective shield that Earth's atmosphere is the protective shield, and that kind of helps us, be sure that the likelihood of something really dangerous happening to us, a really dangerous stellar event happening, is pretty much non-existent. So we're in a safe zone. Okay, thank you so much for watching. We hope you enjoyed our presentation. If you have any questions or concerns, please reach out. And yeah, have a great day.